Today we will discuss about LCS, longest common subsequence. Let's start. The longest common subsequence LCS is defined as the longest subsequence that is common to all the given sequence. Let me explain. You have given two sequences S1 and S2. Here the elements is A, B, C, D, E, and S2 elements is B, C. Now you have to find out the common sequence of these two sequence. So consider CS is A is not here, B is here, C is here, D is not here, E is not here. So common sequence is B and C. We can solve it easily because of the elements of the sequence is few. If you have many elements of sequence in the sequence, how can you solve it? Or a program or a computer how can it solve the problem? So this is the main problem, and we have to solution it with dynamic programming. Here CS is common sequence, S1 is string 1, S2 is string 2. Let's see an example. You have a given sequence string 1 B C D A A C D and given string 2 A C D B A C. The common subsequence are B C C D A C D A C A A C A C C D and many more. Among the subsequence, the longest common subsequence is C D A C. But there is a problem. If you have many elements of your string, so how can you find out the longest common subsequence? This is the problem, and we're gonna make it solve with dynamic programming. I've already mentioned about dynamic programming 2 times in before slides. So what actually is dynamic programming? Dynamic programming is a process where store the results of subproblems so that we do not have to recompute them when we need it later. This simple optimization reduces time complexity from exponential up to polynomial. That's mean we solve a problem with dynamic programming. That's mean main problem had to break down in 2 or 3 more subproblems and solve the subproblems and store the subproblem solutions, and that makes a whole solution of the main problem. Let's see an example about Fibonacci number. Before Fibonacci number 3, we have now we're gonna solve it. Fibonacci number 3 solve with Fibonacci number 2 and Fibonacci number 1. Before Fibonacci number 3 solve, we have to solve Fibonacci number 2 and Fibonacci number 1, and Fibonacci number 2 solve when Fibonacci number 1 is solved. So this is, we have to first solve the Fibonacci number 1. Let's see here Fibonacci number 1 2 times. So it's a problem that we have to solve the Fibonacci number 1 2 times. So how can I minimize it? We can minimize it. We solve the Fibonacci number 1 and store it memory. We solve the Fibonacci number 2, store it in memory, and when we solve the Fibonacci number 3, we call the Fibonacci number 2 result from the memory, and we call the Fibonacci number 1 result from the memory, and we can solve the Fibonacci number 3. This is the process of dynamic programming. And let's talk about where we can use the dynamic programming, or which problem can be solved with the dynamic programming. Those problems can be solved with dynamic programming that have break into the small problem, and this some small problem can be solution in same way. And the solution of the solution of the subproblem is Major solution of the main problem solution. Solving the certain kind of problems where we can use the dynamic programming. Dynamic programming can be used in those problems where the which problem can be solution by recursively or recursion formula. Is it possible to solve LCS with dynamic programming? Let me explain. You are given a string 1 and string 2 ax, yt and a yzx. We break them into two smaller sub problem and we're gonna make it solve. We erase t and we erase here the x, then make them into again sub problem twice and sub problem twice. Did you notice that axy and ayz is solved two times? So when a problem can solve recursively and that problem can break into smaller size and base solution of sub problem make the original solution, this problem can be solved with dynamic programming. That means when a problem can solve with recursively or recursion formula, those problems can solve with dynamic programming. Let's make it solve a sales problem with a dynamic programming. Before solution, we have to learn some process. First column and first row insert 0. Don't worry, I'm gonna explain with the example. Before I will told about some steps, so it is easy to understand the problem and understand the solving way. If don't match, compare between row -1 and column no change and column -1 row no change and replace with the large number. If column -1 and row no change equal to row -1 column no change, we will replace value from the upper. That means the value come from row -1 and column no change. If match, we add 1 diagonal value. Use sign upper, left and diagonals. Let's see an example. We're gonna calculate this value. Here we insert some value. So how can we calculate it? If column -1 and row no change equal to row -1 column no change, we replace value from upper. That means column -1 row no change. This is our column. We're gonna calculate it. Column -1 that means this value, and row no change, that means we are in same row, and row -1 column no change, that means row -1 this row and column no change. We gonna compare 0 and 0. That means we're gonna compare it in these two values. 0 is equal, so we replace the value from upper value is 0, that means 0. That means row -1 column no change, row -1 this row column no change, that means this value come here. And again another step, and use sign upper sign, we using the upper sign. And next another step, if don't match between this value and this value, row -1 column no change, row -1 column no change, and column -1 row no change, column -1 row no change. If these two values don't match, we replace with the large number 0 and 2. Which is the large number? Is yes, obviously 2 is large number, so we replace with 2 and use the left side because this value comes from here. And see the next step, if match, we add 1, that's means +1 with the diagonal value. C and C is match, so we're gonna add +1, we're gonna add +1 here with the diagonal value 0 1 0 +1. That means we replace the value plus 0 +1, this value will be 1. Now I'm gonna make a problem solve. So real problem. We're gonna solve it from Cormen books. The book name is Introduction to Algorithms by Thomas H.Cormen. Page number is 395. In Cormen book we have two strings, x and y. We are going to make a table, and in this table we put the element of y in row B, D, C, A, B, A, B, D, C, A, B, A, and we put the element of x in along to column. First we have to insert a 0 every in this row, and we have to add 0 in this column. Now first I will show you a one step how to calculate this. Compare a and b. A and b is not equal, then 0 compare 0 and 0. 0 and 0 is equal. If equal, replace the value from upper. I already told you that the process. Now see the steps. A and b is not equal. A and b is not equal. 0 and 0 is equal. 0 and 0 is equal. So replace the value from upper. Again, a and d is not equal. A and d is not equal, and 0 and 0 is equal. So replace the value from upper. It's also solved same way. See this. A and E is equal. A and A is equal. So compare 0 and 0. Not compare 0 and 0. Add 1 diagonally. Plus 1 with diagonal value. Again, A and B, compare it. Is not equal A and B. So compare 1 and 0. 1 and 0 is not equal. 1 is greater than 0. So replace the value with 1. And this value comes from left. Again see A and A is equal, and diagonally add 1. See the next. B and B is equal, so add diagonally 1. B and D is not equal. Compare 0 and 1. 1 is greater than 0, so the value comes from left. B and C is not equal, so compare 1 and 0. 1 is greater than 0, so 1 is come from left. Compare B and A, and 1 is equal. So in this procedure, 1 comes from upper. Compare B and B. B and B is equal, so diagonally add 1. 1 plus 1 equal to 2. B and A is not equal, so compare 2 and 1. 2 is greater than 1, so the 2 is come from left. In this procedure we solve the row C, and after solving all the row and columns, we create a complex solution in same way, and this is the solution of the Cormen's problem. After calculation, we will find out the longest common subsequence. So before we start from here and end here. So we start with 0 and end with 4. So from the last count all diagonal value. We count all the diagonal value. So pick the diagonal value and follow the symbol. First we in our end here 4. So 4 comes here from this value. So pick this value come from diagonally, so we pick the 4, and again we go up, because we follow the symbol, we go up, and here this value comes from here, and we pick the value 3 because this come from diagonally, and also going up. After going up, we going to left because this value comes from left, so we going left, and in this stage we pick the value because this value comes from diagonally, and we go to the left value and pick the value because this value also comes from diagonally. I already told that pick the diagonal value and follow the symbol. I pick the diagonally value and follow the symbol and going up. I start here and my end is here, so I backtracking the steps. After complete the steps, we find out all the diagonal value. My diagonal value is 4 3 2 1. Colored all the string which represent the diagonal value. I am coloring all the diagonal value which represent the string. That's mean 4 is diagonal value, so I colored A. Next slide is congratulations, we are solved our longest common subsequence. After coloring this string, we find our longest common subsequence, that is BCBA. BCBA, because when we pick the diagonal value, we colored it. We pick the diagonal value, we colored it. We pick the diagonal value and we colored it. After coloring all the string, we find out the longest common subsequence, and it is BCBA. LCS problem solving with C program. Now we are going to implement it. Here is a short code of LCS problem. First, we declare to header file include studio.h, include string.h. We are using header string because we are working with string. Now declare integer type variable I, j, m, and c two-dimensional array because we are working with 1 0 integer type value. Now we declare character type x, y because we get a, b, c, d, b, d from user, and this that is character, and character type two-dimensional array because we cannot use symbol in C program. We are using character upper left diagonal. For this we need a two-dimensional character type array. Now we are making main function. In main function, first we are print a sentence, then we getting character from user, again we print a sentence and getting character from user first, then we print a sentence. Now we call the function LCS. In LCS we are doing that in x we have some character, and y we have some character. With strlen we get the size of x and we get the size of y, and put it m and n, and make a loop, make a two loop, because we have to fill 0 in first row and first column. That's why this loop. 0 0 is 0, 1 0 is 0, and 0 1 is 0, 2 0 is 0. For this we need to loop. Now this is the diagonal, this is a two-dimensional array. For the two-dimensional table, so we need to loop. In this loop we start from 1 and increment, and the condition will be going with m. Now first we will compare 0 0 0 A and B is match, not match. If match, so we value from diagonally corner, so we diagonally add 1 and represent it is C. If don't match, we compare 0 and 0. If 0 and 0 is match or greater than, we store the value from upper and we represent it upper. If this condition is failed, so the third number condition is we replace the value from left and represent it L. Now we call the print function print mn. Here is we pass the value m and with int I and int j. If I equal to 0 and j equal to 0, the function will not work. That means m is equal to 0 and n is equal to 0. That means this function or that function will not work. If this condition is not true, then second line will execute. If we are consider this value, if this value from corner, we print it, we call the print function again and check it again. After checking, we print the value. If this value from not corner is execute this line. If the value from upper is upper, print this line, or this value is not from upper or corner, print this line. Time complexity of LCS is order of n into m. Cause we solve the problem with dynamic programming. If we solve the problem with recursively, the time complexity will be order 2 to the power n into m. So it's huge. That's why we solve the problem with dynamic programming and it reduces the time complexity. So why this is order of n into m? Since we are using two for loops for both the strings, therefore the time complexity of finding the longest common subsequence using dynamic programming approach is order of n into m, where n and m are the length of the strings. Since the implementation involves only n rows and m columns for building DP two-dimensional array, therefore the space complexity also order of n into m. Let's see the code. See, we use only two loops for solving the table LCS problem. That's why the time complexity of LCS is order of n into m. So this is our end. Thanks everyone. Thanks for watching. Allah Hafiz.